Hi everyone, welcome back to the Linux. Today we are going to see about logistic regression. The logistic regression is in a supervised machine learning used for classification tasks. The main goal is to determine the probability of a data belongs to which classes, and the class which has a higher probability then the data belongs to its class. And it is in a statistical model and it used the linear regression equation. Let's take for example, let's take z equal to w1 x1 plus w2 x2 and wnxn plus b, where xn sorry where the n is the number of futures or the number of inputs, and w is called as coefficients of an x1, or we can define as how much the z will changes upon changing the x, where the b is constant. Assumptions of logistic regression. The outcome is always in a categorical, and each observation are independent. For example, let's take a sample data set of size 1000, 1 to up to 1000, and each input is independent from each other or independent. The one is independent to the two, and there is no multicollinearity among the independent variable. Means, for example, let's take a logistic regression equation as w1 x1 plus w2 x2. For simplicity, we can take as two input, where x1 is also called as independent variable. X1 and x2 are called as independent variable, where z is called as dependent variable. And there is no multicollinearity, means there is no relationship between the x1 and x2. And in logistic regression, usually prefer the large size of samples, and there is a linear relationship between the log odds and the independent variables. This means there is a linear relationship between these independent variables to the dependent variable throughout its coefficients, and it's constant. There are three types of logistic regression: binary logistic regression, multinomial logistic regression, and ordinal logistic regression. First, we will see the binary logistic regression. In name itself, we can understand that there is two logistics. There is only two classes. Let's take class 1 and class 2. And each classes have the logistic equation. For example, z equal to w1 x1 plus b. For simplicity, I take just one input, and z2. This is class 1. This is class 2 equal to w1 x1 plus b. For example, then the inputs, let's take x equal to x. When the input like x will comes, it will first identify the value of n, or it will find the value of n z. For example, when upon substituting the x1 and w1 and b, it will return some value as x1, and class 2 will return as the z2. And we will put this continuous value into in a sigmoid function. The sigmoid function always return the value in the range of 0 to 1. This is nothing but it's a probability of any data belongs to that class. For example, um, the sigmoid function equation is p of z equal to 1 by 1 plus e power minus z, where the z is logistic regression equation value. And it will we also find the logistic equation for in a class 2 and put it into the sigmoid function, and we found the probability of an data belongs to each classes. But there is no need to find the class 2 probability of a class 2, because the overall probability of a data is 1. For example, let's take in a probability of an x belongs to in a class 1 is p, and probability of an x belongs to in a class 2 is q. The overall probability is 1, and we found the probability of a data belongs to each classes. We sum them up of in a probability of each data belongs to each classes, and it's always equal to 1. Let's write that p plus q equal to 1. If p plus q equal to 1, I just rewrite the equation for n q. Let's take q equal to 1 minus p. This means I found the q, I will found the q based on the p. So I don't need to find the or train the model for the class 2, and I don't need to put in the logistic or sigmoid functions. What I will do is I will just write the only one logistic regression for in a class 1. I will train them according for in a class 1. Once I found the probability by a sigmoid function, I just subtract by in a 1. Then I will found the probability of in a x belongs to class 2. So there is only one regression equation used in the binary logistic regression. We don't need to write the logistic regression for an class 2. We don't need the sigmoid function for an class 2. What we'll do was we simply find the continuous value for an class 1, and we will put in the continuous value in the sigmoid function that will return the value as 0 to 1, and that is nothing but is in a probability. Once we find the probability, we simply minus it from 1, and we found the probability of a class 2, and data will goes the probability of a class which has higher. For example, p is equal to 0.9 and q is equal to 0.1. Among this, the 0.9 is in a higher, so x belongs to a class 1. Multinomial logistic regression. In name itself, we can found that there is multiple classes, more than 2 classes, and unordered classes. For example, let's take class 1, class 2, and class 3. For simplicity, we can take 3 classes. And unlike the binomial logistic regression, we will use the log softmax function. This equation of softmax function is p of z equal to e of z of j divided by summation of e of e power z of I, where I equal to 0 to n, where n is the number of classes. Okay, where n is the number of classes. In this, wait, mm, in this also each class has a regression equation. For simplicity, we can take as input as number of input as 1. So when the input input like x1, it will goes to the each regression equation in the classes, and each regression classes will return some continuous value as z, z1 and z2 and z3 for this input x1. And after finding the continuous value, each class put in the softmax function. This is in a softmax function. P of z equal to e power z of j by summation of e of z. For example, the probability of x belongs to class 1 is p of z1 is e power z1 divided by e power z of I plus e power z of j plus e power z of e power z of 3. This is 2, this is 1. This is a simple equation. It will calculate the probability of a data belongs to each class. This is for a class 1. We similarly do for a class 2 and similarly do for a class 3. In this also, some of the probability of each class is always equal to 1. Sum of the probability of data of each classes is always equal to 1. And the data will goes in the class which has an higher probability. For example, class 1 p of z1 is equal to 0.6 and p of z2 equal to 0.2 and p of z3 equal to 0.2. And in this case the x1 belongs to a class 1 because it has the class 1 has a higher probability. Ordinal logistic regressions. In this we use the ordered classes. Unlike the multinomial logistic regression, we can see that there is unordered classes. This means there is no relationship between the class 1 and the class 2. But in the ordinal logistic regression, there is an ordered categories. This means like poor, good, excellent. When the new input is comes like in a dog, it's based on the probability. It will tell us poor dog, good dog, or an excellence, like that. Unlike the other types, it use the cumulative logistic functions. In binomial logistic function, it will use the sigmoid function, and in multinomial, it use the softmax function. But in the logistic regression, it will use the regression equation. Unlike the others, the ordinal logistic regression use only one regression equation. For example, let's take it will have an n number of classes. For simplicity, we can take three class 1, class 2, and class 3. And for all the classes, it will use only one common regression equation. For simplicity, we can take the number of input as 2. It uses the cumulative for logistic function. For example, it will the equation looks like p of y lesser than j equal to 1 by 1 plus e power minus theta j. Theta j is here it is like the w1 for an cumulative logistic function. It is in a coefficients minus this all the entire term. This entire term is nothing but it is in a set. So for writing the entire term, we can simply written as minus set. This set is called as logistic regression. It is all the formulas are similar, right? Fine, but it will minus theta j minus. It will minus some theta j. It is called as constant, and it will update on each iterations. Or we can say that is like constant for each model. And class probabilities from the difference of cumulative values. Class probability from the difference of cumulative values means each class having a probability. It will return the probability. For example, there is three classes. It will find the p of 1 for a class 1, p of class 2, and p of class 3. And the data will grows on the class which has a higher probability. For example, p1 has a probability of 0.6 and p2 has a probability of 0.8 and p3 has the probability as 0.9. The probability here, the probability among this, the 9 is higher. So the data like x1 goes in the class 3. Unlike the others, the each class, the sum of the probabilities, it's not always equal to 1. It may differ. How does the logistic regression works? First, it will compute the linear combination of inputs like the logistic regression, as I said, and apply the transformation function based on the which type we are using, like binomial or a multinomial or logistic ordinal regression, it will put it according to its functions, and it will give the probability of any data belongs to that classes, and it will get the probability from the each classes, and it will choose the class for any data in which class it belongs to based on the probability which the class it has a higher probability. Real world examples. In real world, it will predict the student will pass or fail based on the number of hours he will study, and credit card risk prediction like good, bad, average, and medical diagnosis whether the patient have any disease or there is no disease. How the logistic regression train? We know that first we will there are around steps to train the model. First, we will collect the data and then we pre-process the data, like removing some removing some inputs which has in a no data and missing columns or missing values in the rows. We will remove the missing rows. We will remove the missing values or we will fill the values. And third one is training. We will train the model and we will test the model and we will predict and model evaluations. Sorry. First we will collect the data, right? And we will predict the and we will pre-process the data and we will train. During the training process, how it will train the model, right? Because it will train, we need to train well, right? So that it will predict the data upon unseen data. During the training process, it will initialize the coefficients. As I said, the linear regression equation is w1 x1 plus w2 x2 and plus b, where the w1 and w2 are the coefficients, right? The x1 or x2 are given by a user or in the data set. We will take that, but w1 w2 are importance. The model will always update the w1 and x2 based on the predictions and the error, and b is called as bias, or we can say as intercept. Each iteration, sorry, each iteration it will compute the predictions. For example, for the input like x1, the input like x1 x2 is given, and based on the initial weights it will predict the z. Okay, based on the initial weight and the input it will predict the z, and it will calculate the loss. Basically in the it is in a supervised learning, right? So it has an actual output along with it. First, it will predict based on the model and compare its result, actual output, actual output, and compare its prediction to its actual output, and find the loss function. Find the loss function by a cross entropy. There is a function called as cross entropy. It is used for finding the loss of any loss for an actual prediction to the for the prediction by a model to an actual prediction, and we will update the coefficients, and after the each iteration we will update its if coefficients w1 and x1, and this is the loss function. Okay, this is the log function. W is in a previous w is in a previous sorry previous weight, and alpha is the learning rate. The alpha is in a learning rate, and this is in a loss function. We will differentiate the loss function and put the prediction value, and it will update automatically. Once again, these are the sample steps. First, it will predict if the student passed based on the study hours. Sorry, the model will predict the student sorry, the model it's predict the student is passed or not based on the study hours. First, we will initialize the weight 0.5 and 0. We can initialize any value, any value based on the needs, and the inputs like x1. The logistic function it looks like z equal to w x1 wx plus b. Initially, the b w is 0.5 and b is 0 0, and the input is given as z x equal to 2. Okay, the actual input is also given. For example, if z equal to w1 x1 plus b, and where given is w equal to 0.5 and b is equal to 0, and input is 2. If I found the z equal to 0.5 plus 0, sorry, 0.5 into 2 plus 0, the output is 1. Z is 1. That is 1 here. And we will put this equation in sigmoid function. In this case, we will use the sigmoid function, but based on the types we are using the logistic function, we will put in sigmoid function or in a softmax function or cumulative logistic function. In this case, we will put in the logistic function, sorry, sigmoid function, where sigmoid function equal to y bar equal to 1 plus 1 by, sorry, 1 by 1 plus e power minus z, where the z is 1, right? So we directly put 1. So the output of an probability is output of an z is 0.37, right? It is in a probability, so it goes in a class 1. Okay, there is, I told you there is a loss function to update the coefficients. This is in a loss function. You can see that y into log of y plus 1 minus y into log of 1 minus y, and the loss function returns the value by comparing the actual predictions, that is 0.67, and comparing the, sorry, comparing the predictions and the actual value, then returns the value as 0.313. Based on this value, it will update the w based on this equation. And that's it from this video. In next video we will discuss another algorithms. Thank you. Let's see you on next video. If you have any doubts, leave it in the comment.